In this lesson, we are looking at relating factors to zeros. Let's remember what these two words mean real quick. A factor is something like x plus c, where you have x plus 2 or x plus 5. It's a zero is of the form x equals a number. So x equals minus c. And remember, zeros are also called x-intercepts or roots. Let's also talk about the things we know. We know how to graph a quadratic. If I give you an equation, you can plot the points to make a graph. We know how to find the zeros of a quadratic graphically because they're just the x-intercepts. We know how to factor a quadratic. That's what we've been doing in the past couple days. Now we're going to look at the relationship between these three things. I have a graph over here on the right. My graph has two x-intercepts, or zeros. The values of those zeros are x equals 4 and x equals 6. If we wanted to write the equation of this parabola, I usually write my equation in vertex form. So I'd start with y equals. In order to move my vertex over here, which would be 5 units to the right, I need to put a minus 5 on the inside of my x squared. It's an x squared because it makes a U shape. In order to move my graph down 1 unit for my vertex, I need to put a minus 1 on the end. Question number 3 asks, what is the equation of the parabola in standard form? Standard form for a quadratic is ax squared plus bx plus c. So in other words, I need to take my equation from number 2 and I need to multiply that out. I would start out following order of operations and square first. So I have x minus 5 times x minus 5. That's going to equal x squared minus 5x plus 25. I can either do that by foiling or doing boxes. Remember, I also have the minus 1 on the end. My last step would be to combine like terms. I'll have x squared minus 10x plus 24, and this is the equation in standard form. The equation we had up here, we usually refer to that as vertex form because I can tell that the vertex or anchor point of my graph was at 5, -1. In question number 4, I'm looking for the factored form of the quadratic. To do that, I'm going to think of my original equation. The quadratic part was x squared minus 10x plus 24. To factor this equation, I'm looking for what two numbers multiply to 24 and add to -10. In order to multiply to a positive, I need to have two numbers with the same sign. So -6 times -4 is going to multiply to 24, and -6 plus -4 is going to add to -10. So I can rewrite this in factored form as x minus 6 and x minus 4. This was an equation, so I'm going to leave my y equals there. That was original, and this is what we call factored form. You need to know the names for these three forms of a quadratic. We have factored form. In number 3, we had standard form. And like I said, in number 2, we had vertex form. So you need to recognize those three forms so you can follow directions. So the last question, number 5, says, how are the zeros related to the factors? We recall from number 1 that the zeros of our equation were x equals 4 and x equals 6. After we rearranged our equation, we got the factors of our equation. The factors of our equation were x minus 6 and x minus 4. So how are the zeros and the factors related? Whoops. They have the same numbers but opposite signs. So my 0 was x equals 4. My factor was x minus 4. If my 0 was x equals 6, then my factor was x minus 6. In question number 6, we're starting with the factors of a quadratic. The factors of the quadratic are x plus 1 and x minus 3. Using the knowledge we have from above, that means x plus 1 could equal 0 to make a 0, so x equals negative 1. And x minus 3 could equal 0, so x could equal positive 3. So the zeros of my quadratic are x equals negative 1 and x equals 3. Question B asks me for the equation of the quadratic in standard form. Well, I started out with factored form of x plus 1 times x minus 3. I need to either FOIL or do boxes, which will give me x squared plus 1x minus 3x minus 3. And last, I need to combine like terms. I have x squared minus 2x minus 3, and that's the standard form for my quadratic. Now I'm supposed to graph my quadratic using my calculator. So I'm going to put my calculator in my graph mode. I'm going to type in my equation of x squared minus 2x minus 3. I'm going to reset my view window to standard, and I'm going to draw this picture. So I can see it's scooched over to the right, it's scooched down some. If I want to know some points, I can go into the table menu of my calculator. Let me be sure I'm set up to go from negative 10 to 10, because those are the points I like. And I could look at a table. As far as plotting the points go, these first points of my table are all pretty big. I'm not going to plot them because they're double digits and they're not going to fit on my graph. But there's something that could fit. Negative 2, 5, negative 1, 0, 0, 3, 1, negative 4, 2, negative 3, 3, 0. All of these points that are single digits are going to fit. So I'm going to pause the video for a second while I plot them on my calculator. So I plotted those points, and then when I connect them, I'm going to make my nice smooth parabola shape. I'm going to have arrows on both ends showing that it goes up forever. So what are the x-intercepts of the quadratic? The x-intercepts are x equals negative 1. I can also write that as negative 1, 0 if I want to write it as point. And x equals 3, which I could also write as 3, 0 if I wanted to write it as point. So does this seem like it's working out? The x-intercepts of the quadratic are the same as the zeros of the quadratic. Everything looks good so far. On number 7, we're starting with the zeros of the quadratic. The zeros of the quadratic are x equals negative 4 and x equals 2. Pause the video while you try to answer all the parts from question number 7 for this quadratic. If the 0 is x equals negative 4, then the factor is x plus 4. If the 0 is x equals negative or positive 2, then the factor is x minus 2. To graph this quadratic, I can tell right now that I'm going to have an x-intercept at negative 4, an x-intercept at 2. I could also use my calculator to plot the points. So I got the points off my calculator in the table menu, and I plotted them up there. To write the equation of the quadratic in vertex form, I need to know where is the vertex, or my anchor point for this graph. That was at negative 1, negative 9. So if I'm going to write the equation, I need to move 1 to the left, which I do by putting a plus 1 inside my function. I need to move down 9, so I put a minus 9 on the end. It said up here, assume that a equals 1. That's what all of these have been so far. I haven't stretched or shrunk anything, so there's never been a multiplier out in front here. All right, in part D, we're supposed to write the equation of the quadratic in standard form. To do that, I have to start out by multiplying the x plus 1 and squaring it. When I square x plus 1, I have to FOIL or do boxes, and that gives me 4 terms. Next, I'm going to combine my like terms, and I'll have x squared plus 2x minus 8. That's standard form for this quadratic. Now I could start with my standard form and factor it. If I wanted to factor this equation, I would be looking for what two things multiply to give me -8 and add to give me +2. To multiply to -8, one has to be positive and the other has to be negative. How do I get to 8? Well, I could do 4 times 2, and +4 times -2 would also add to give me +2 in the middle. So my two factors, since there's no leading coefficient, I can just jump right in to x plus 4 and x minus 2. So there is factored form of my equation. Also in this question, it asked me, is my answer to this part the same as the answer to question from part A? And here was part A up at the top. X plus 4 and x minus 2 were my two factors. Yes, they are. So I can tell factored form, standard form, vertex form, they're all giving me the same parabola with the same zeros. In question number 8, we have a little more complicated parabola. We have y equals -2x squared minus 12x minus 10. The first thing I'm asked to do with this is to factor the quadratic. Don't forget, when we're factoring a quadratic, the first thing we always want to look for is a GCF. -2 goes into all of my terms. If I factor a -2 out, it becomes x squared, then it will become a plus 6x because I've taken the negative, and a plus 5 because I've taken the negative. Now I need to factor what's left on the inside. If I'm just dealing with the inside, I want to find what two things multiply to 5 and add to 6. Since they're both positive, both of my factors need to be positive. The only way to multiply to 5 is 1 times 5. Fortunately, that also adds to 6. So my two factors are x plus 5 and x plus 1. Remember, I still had from the beginning of my problem the -2 factor out in front, and this is the factored form of my equation. In part B, we're supposed to find the zeros of the quadratic. To find the zeros of a quadratic, we set each factor equal to 0. If I set the -2 equal to 0, that's not going to have any solutions because 2 can never equal 0. So I don't have to worry about that one giving me a 0. If I set the x plus 5 equal to 0, then my factor is x equals -5, or my 0 is x equals -5. If I set my factor of x plus 1 equal to 0, then my 0 is x equals -1. So my zeros of this quadratic are -5 and -1. If I wanted to use this to help me graph in the next part, I could put on 1, 2, 3, 4, -5 and -1 as my zeros. And if I wanted to just throw up a quick sketch, that would all be I really need to put on there. If I want to plot some more accurate points, I'm going to need to look at the table menu of my calculator. Or to work this out, the other thing I should realize is that really my graph would be upside down because I have a -2 out in front. So my parabola needs to be flipped over. And let's just go ahead and use the table to get the rest of our graph. So I put this in my calculator, I used my table, and I got the remaining points that I needed. What should we be getting out of this assignment? We should realize the relationship between the factors and the zeros, that they're opposite signs. And we should also realize that we have three forms of quadratics. We have our factored form, our standard form, and our vertex form.